let's look at a quick review of making a rhombus. So, reminder, what is a rhombus? A rhombus is a quadrilateral with all sides of equal length. Okay, so making a rhombus is the trickiest shape that we've had to make. So, use my straight edge part of my protractor. I'm going to make each side 2 inches. So if this is on the 5 inch mark, I'm going to have to go down to the 3 inch mark down here. Okay, so there's one side. Now the angle here doesn't matter for our purposes right now. So I draw another 2 inch side. It was a little bit too much, a little too long. And then the tricky part with the rhombus is getting that the parallel side also 2 inches. So I'm going to put my right angle template on, and I'm going to line it up really closely with the end point of this top line segment. Okay, so right about there, and then move my straight edge up there. And the whole point is that I'm trying to make a side that is parallel to this. Right now, the side is perpendicular. So let's see, let's do it like that. So, all right, now I can see that I can make a parallel side there, except I want to use the straight edge and not the right angle template to be drawing my sides. And it's going to need to be 2 inches, same as the other. So that's going to go from the 1 inch mark, to the 4 inch mark. No, that's not right. These were all 2 inches, right? So the 1 inch mark to the 3 inch mark. So there. And then to close this figure, if I've done everything well, then this line should be parallel to the, I guess, second line that I drew. And it should also be 2 inches, and I can see that it is. So each of my sides on my rhombus are the same length. They are 2 inches, and we'll call it A, B, C, D. And then a couple of other things that you need to remember. Angle A is equivalent to angle C. Angle A is equivalent to angle C. Angle B is equivalent to angle D. Line segment BC is equivalent to line segment CD, and so on, all the way around. And what was the other? Oh, yeah. Importantly, the diagonals bisect one another, and they are perpendicular to one another. So you can tell that they're perpendicular. It doesn't look like I didn't make it perfect. Doesn't look like they bisect each other perfectly well. But so if this is the midpoint, they are perpendicular. So BD is perpendicular to AC. They are perpendicular bisectors. And if you want to look more closely at a rhombus, you can just go back to the rhombus, the main rhombus video, and I talk about all of this in more detail. But I just wanted to take a quick look at that since it's been a week since we've studied them. Okay, now I will be right back. Okay, I want us to look at a rectangle carefully now. Now, a rectangle is not super difficult to draw, especially compared to a rhombus, which is kind of a challenge to draw. What is a rectangle? A rectangle is a quadrilateral with 4 right angles. And you might be thinking, oh, wait a second, a square is a quadrilateral with 4 right angles. And that's true. A square is a special rectangle. All right, so let's do, I'm going to make a line. And I'm doing these kind of, most of the time when I'm making these shapes, I'm not making them right along my notebook paper lines, because I want you to see that it doesn't have to sit perfectly square on your notebook paper, right? All right, so let's make a line right about here, and I'm not going to worry too much about the length of this line. I do need to have a perpendicular line, right? So I need to have a right angle there. So I'm going to use my right angle template. And there we go. So right angle template. I know I moved it a tiny bit. So there. And now I'm making another line that is parallel to that. Whoops. I saw it move a tiny bit again. I need to be more careful. Okay. So I know that this is a right angle. And now I just need to make one more right angle. Oh, I guess I'm actually making two more right angles here, right? Okay, so we have a rectangle, and we'll call it rectangle A, B, C, D. And the key part of this rectangle is that it has four right angles. Angle A, B, C, and D are all four right angles. Additionally, it's a parallelogram, so it has parallel sides. And actually, now that I think about it, I probably should have made those sides parallel first. Well, maybe it doesn't matter. Okay, so yeah, side AD, line segment AD is parallel to line segment BC. Line segment AB is parallel to line segment DC. Okay, so let's write some of that down. AB is parallel to DC. That symbol means parallel. Let's see, DC, AB, DC. AD is parallel to BC. I said sign, I should have said symbol. AD is parallel to BC, line segment BC. Line segment AD is perpendicular to line segment DC. AD is perpendicular to DC, and that's just noting that that's a right angle. AD, DC, and AB is perpendicular to BC. AB is perpendicular to BC, to line segment BC. Let's look at the diagonals. So this is a parallelogram, it's a quadrilateral. It's going to share some of the same features. Well, it'll share all the same features of a parallelogram. Let's see. If we call that M, midpoint, or rather M, and does it bisect these sides, I wonder? That's the next question, isn't it, I guess? So that is about 3 centimeters. So MB is 3 centimeters. DM is 3 centimeters. AM is 3 centimeters. And MC is 3 centimeters. So the diagonals bisect one another. And what else did I want? So the interior angles, you can see that this angle, this would be angle AMD plus angle AMB is going to equal 180 degrees. So AMD that's this angle, is going to plus angle AMB is going to equal 180 degrees. And let's just have a quick look here. Let's extend this out. So that is, what is that? That is about That's an acute angle, less than 90 degrees. 50, 52, something like that. 52 degrees. And we already know that this is going to have to equal this angle AMB. Let's see, so AMD is 52. Angle AMB is going to have to be 1, let's see, 180 minus 52 is 118, 128. Double check that. Yeah. Okay, so does it equal 128? And you can see that it does. So 120. Again, that's, I mean, if you know that this is 52 and you know that's a straight line, then you hardly need to measure it to know that it's 128. So this angle, BMC, is also going to be 52. And this angle, DMC, is also going to be 128. And the sum of all angles, of course, of all angles equals 360 degrees. Maybe we should say sum of all internal. Okay. All right, I think that covers what we need for a rectangle. All right, very good.